Welcome back, students. So we shall continue our conversation about the relationship between two quantitative variables. I'm going to do two things today. First, I'm going to walk you through an example from start to finish. And second, in context, I'm going to show you some features of the graphing calculator that's going to help you compute a lot of things with a minimum time to save time. You do need to know how to operate the calculator. So make sure you have your calculator on you and your passion for mathematics, and you shall do very well today. So please pay close attention. The very first thing I want you to do is to pause the video and copy these data points under stat edits under L1 and L2. You may remember we had a price of trucks, which is the second row, in relation to the number of miles driven, which is the first row. So you need to go to stat edits and enter under L1, enter your X values, or the miles driven. Start with 70,583 all the way to 4447, and then come down to 34077 all the way to 131,385. Once you finish, you go to under L2 and you enter the price of those trucks in dollars, and that is your response variable. So you start with 21,994, go all the way here, all the way to here. So the last number should be 13,997. And make sure that your numbers match up. In other words, this should go with that and that should go with that. You don't want to take this mileage and associate it with this price, okay? So please don't sort your numbers because you're going to mess up the order, okay? So I'll give you a minute, and when you finish, then we will proceed. I'm going to minimize this again. So I hope you froze the computer and enter all the data. Make sure you double check. When I entered my data, I double checked every number to see if everything is good. Because if you make one mistake, you're not going to get the values we're going to get, okay? So now that you have entered the data under L1 and L2, so you went to stat, you went to edit. L1, you put the miles driven, and under L2, you put the price of those trucks in dollars. So this is like $34,995, okay? And last time I showed you this image, this scatter plots, this stuff in red. Don't pay attention to the blue line, just the stuff in red. That's your scatter plot. It's basically sketching those data points. And the way we do it is you go to stat plot and turn on your first plot or second, whichever you want. Go to stat plot, turn one of them on. I usually turn on the first one. The way you find it, it's second Y. That's how you get to stat plot. And you have those 6 boxes again. We've said this many times. So it's this one. Okay, 2 of them deal with box plots and modified box plots, and I think these 2, and this one deals with the normal probability plots. You want the very first one, okay? You click on that one, and what you want to do, you may not necessarily see the scatter plots because your window is messed up. So what I would like you to do is to go to Zoom Statistics or Zoom 9. Click on Zoom. Scroll down to 9, or just press number 9, and it'll take you to Zoom Statistics. Press enter, and you should be able to see the scatter plots. If you don't see the scatter plots, you've got to freeze the computer, the video, and go back and figure out what went wrong. Maybe you didn't enter the data correctly. You should have all of these red dots, and they should look exactly the way they look on your calculator. So now, how do we clearly, these points here, there is no line that captures all of these points. And we talked last time about the least square regression line. And how do we get this line to be drawn number one. And number two, how do we get the equation? Okay, and it's not hard at all. Why? Because of the calculator. So what I would like you to do then is to go to Stats, Calc, and scroll down to number 8. I know number 4 also have a line called AX plus B. I don't want you to use that. I want you to scroll down to number 8 or just press the digit 8, and it's going to take you to linear regression A plus BX. Notice how it is written. A is basically your y-intercept and B is your slope, okay? Press enter and you should have these 4 numbers on your screen. If you don't see r squared and r, you need to go back to the previous video and figure out how to turn on the diagnostics because this is going to be very helpful to you, and you have no way to do this because we're not going to use the algebraic method. So make sure you go back to the previous video and figure out how to do this. Turn on the diagnostics, start over again, and once you press enter, you should see all these 4 numbers. Okay? Now, I'm going to pause here for a while and address these issues. Number one, don't worry about r squared yet. Okay? At all. Just don't worry about it. I know r squared is just the square of r. If you square this number, you're going to get that number. But this particular number has a specific interpretation, so please don't pay attention to it. You will find out that A, this A here, is 38,257.14, and I'm approximating. Notice that I'm not writing the equal sign because I knocked off some decimals, okay? And B is this number, and R is that number. So, first, notice that R is negative. That is expected because the association here is negative. It's not positive, but it is negative. So you expected it to be negative. Second, it doesn't look bad. This scatter plot doesn't look bad. So I was expecting something around negative 8.5, negative 0.8, negative 0.78, something of that sort. We got negative 0.815. That is reasonable. That is reasonable. That is kind of what I'm expecting. If I had gotten a positive number, I know I'm wrong. If I had gotten negative 1, I know I'm wrong. If I had gotten negative 0.5, I know I'm wrong. So this number is very reasonable. Second, I know you know what a y-intercept means and what the slope means. You really need to know how to interpret them in context. So this means this A here, I wrote it here by the way, y equals A plus, there is a negative, okay? A plus bx. Now, your calculator will give you this, right? That's what it is. You need to think of this y as a y hat because this is predicted. It's not observed. These are observed. These y's are observed. These y's are predicted by the line. So you got to put a hat on paper when you do it on paper. In fact, I wrote it this way. Price hat, because I'm trying to know what y is, y was the price, equals A plus B x, and x was the mileage driven. Yeah? So this is basically the line, and we are going to be able to graph this line. But let me pause here and interpret these first. Since this is the y-intercept, it means it is the initial value. It means initially with no mileage, basically a brand new car should cost $38,257.14. Notice what I said, should cost. It doesn't cost, it should cost, based on the line. Based on the model that we are superimposing, we expect a brand new car would cost $38,257.14. That's what we expect. Okay? Now, how do you interpret the slope? So go back to a basic math course. The slope is negative 0.1629. Let's divide it by 1 so you could see it. Remember that this is the price and this is the mileage, right? The rise over the run. So for every extra mile driven, you're expected to lose a little over 16 cents. That's what it means. So if I say interpret the slope in context, you'll say for every additional mile that is driven, the car is expected to lose a little over 16 cents. If you don't like one and it looks weird, you can write it like this. Right? Multiply top and bottom by 1,000. And you could say for every additional 1,000 miles, the car is expected to lose $162.90. Lose. It should make sense. Or maybe you may want to do this. For every additional 100 miles driven, the car is expected to lose $16.29. Make sure you say lose, okay? Because there is a negative sign. That is the interpretation of the slope, okay? And the y-intercept is easy. It's just the price, the expected price of a brand new car. Expected, not necessarily true. You could go to the dealership and they might quote 40,000 or 37,000, but based on this regression line, which we are going to superimpose in a minute, you're expected to pay $38,257.14 for a brand new, the mileage is 0. Okay, so that is the y-intercept. Okay, so important. They always ask this question on the AP. Interpret the y-intercept in context. I never call this the y-intercept. I always call it the initial value. Okay, interpret the slope in context. And we already talked about R. We expected it to be negative. It looks fairly strong. You know, I would say the association between the number of miles and the price is fairly strong, and it's negatively correlated, right? Now, there are two ways to drop this line. Two ways. One way, since this is on your home screen, you copy these numbers on a piece of paper. You go to y equals, you know, y1. You have y1 on your calculator. And you literally just enter them. 38.2 minus this x. Okay? And you press graph. You don't have to work with the window anymore because you already have clicked on zoom 9 and your scatter plot is already beautifully written for you. You don't have to do anything other than press graph. And you should see this line. And if you don't see this line, you got to go back, freeze the computer, the video, and figure out what you did wrong. Okay, so that's one way to do it. The problem with this method is, number one, you have to copy these. You can't see when you're under y equals. You can't see the home screen. So number one, you have to copy these on a piece of paper. Number two, you are approximating. I'm sure there is more dots, more digits here, and I knocked them off. So you're only going to copy what you wrote, right? There is a better way. There is a better way. You don't have to know. You don't have to do this, but there is a better way. Here's how you do it. Once you have these on your screen, you must have them on the screen first, okay? You've got to go through this process and get this on the screen. Here's what you do. You go to y1 equals, you know how you always graph functions, top left, the gray button, y1 equals, and you click on vars, but go here first, okay? You got to go here first. There is a button next to the scroll up, down, left, right, just a little bit underneath. It's right next to clear. It's called vars. Click on vars. Once you click on vars, go to the right. Scroll down to number 5. It's called statistics. Okay. You click on it, press enter. Okay. And then scroll to the right where it says EQ. You'll see XY, sigma, EQ, test, points. You click on EQ. Once you click on EQ, you click enter. And it's gonna go to your Y and it's gonna enter all of your numbers for you for free with all the decimals that were attached in the first place. It just does it for you directly. Press enter and you should be able to see the graph, the superimposed line, the regression line. It's called the least square regression line. And I explained last time why is it called the least square regression line. Okay, so now, and on your paper, this is how you should always write it. Okay, price hat, and then the initial value, slope, and then the mileage. Make sure you put a hat. If you don't put a hat, you will be incorrect. Okay, so I'm going to conclude with another concept called the residual, which is the error. So for instance, this observed value in red, let me enlarge this for you. This observed value in red matches the y value through the regression line. So there is no error. The error is 0. This observed, let's call it y, and here is the y hats based on the line. And the residual, if you remember, is y minus y hat. So you could see that this error is negative. This error is positive. This error is positive. This is negative. This one is negative, and so on and so forth. Make sense? The question is, how do we compute these errors? How do we find the errors? Because these are errors. Positive error, negative error, positive error, positive error, positive error, negative error, and so on and so forth. How do we compute those errors? I'm going to show you how to do it by hand on one point only, like this one, as an example. And then I'm going to show you how to compute all of them in one shot. Okay? Did you hear what I just said? How to compute all of those errors in one shot. Okay? So let's just pick, let's say the first point, this one. This first point has a name called 70,583, comma. This is not comma here. It's just I'm used to, using dollar value. We put a comma here. Okay, I'll start over. 70,583, comma, and the price was 21,994. Okay. For this particular point, I want to find the error. So how do we find the error? By the way, when you are on your graphing calculator, if you click on trace, and you use the arrows left and right, up and down, you can hop between the points, and you'll know which points belongs to which of these. Like if you want to know who's this point and who's that one and who's that one, you just press trace and use the left and right arrow, and it'll hop, and it'll tell you what the point is. It'll just hop. Like if you click on this one, it'll give you the points, so you'll know which point you're referring to. So I believe that this point here, which is the first one here, when I was on my calculator, it was this point here. I'll highlight it for you. I believe it was this point. So notice that the error is negative, right? So I expect a negative error. It's not very big, but it's not small either. It's not like this small error here, or 0 error, or a big error for this guy, right? It's a fairly medium-sized error, and it's negative. That's what I expect to get. So let's see how you do it. Okay. Notice by definition, residual or error is y minus y hat. Y is just the observed. It's this guy. XY, 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 XY. So that's the y. That's a joke. You just copy it. What is y hat? Y hat means go back to the regression line and plug in the x value here and multiply this number by this and subtract it from this, and I got 26,758. Make sure you know how to do y hats, right? You just plug in this point. Don't plug it in here and get this is observed. Okay, it's done. You've got to plug in this one in your regression line to figure out the y value. It's called y hats or price hats. So that error happens to be negative, as expected, negative 4,764. So for this particular data points with these many miles, with this price, according to the least square of regression line, there is an error of negative $4,764. Basically, this regression line underestimated the price by underestimated, I said, right? Underestimated the price by $4,764. And I would even do this. I would even actually write it like this. Right? Because this is a dollar amount. Notice Y is a dollar amount, right? Price. So price minus price is still price. Okay? So that is the residual for this point only, which happens to be this point. Now, if I ask you to find all the residuals, it's a joke. I mean, it'll take you like 2 hours. you gotta repeat this for all the points. And I think there are 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You gotta do this 16 times. And you don't want to do that by hand. Although you should know how to do it by hand. Because on a test, I'll give you 1 point and I'll ask you to find the error or the residual. So you should be able to compute this. Okay? So, and that's how I want to conclude and show you one little fact. So, this is what you have right now on your calculator, right? You started with 70,000, you ended with 131,385. They're not in order whatsoever. And here is your prices. And notice that goes with that. You cannot mix this with this or that with that or that with this. They need to be paired like this. This is a pair, this is a pair, this is a pair, this is a pair. So don't mix up the X's and the Y's. And I just found that the residual is this. What I want to do next is under L3, I want to produce all the errors in one shot. With 3 presses of a button, with a press of a button 3 times or 4 times, I should be able to compute all the residuals, whether you have 16 of them or just 1 of them or 1,000,000 of them. I want to be able to compute all of them. I've already computed the first one, and let's see if we are correct. So here is what you do. Pay attention now. This is the last page, okay? Go to Stat Edit where you see L1 and L2, and you're going to go under L3, and I want you to push up the cursor and highlight L3. If you don't stand here. You gotta press the cursor up and click on L3. You will see L3 equals blink, blink, blink. You'll see L3 equals, and it's waiting for you to enter some information, right? So let's reason. Now the residual is Y minus Y hat. Now what is Y? Y is just L2. So you write L2. So how the heck am I supposed to say Y hat? Y hat is a function. How am I supposed to say, please enter this here and get a Y hat? Please enter this here and get a new Y hat? How am I supposed to say that? Here's how you do it. Y, which is L2, that's easy, minus Y hat. What is Y hat? Y hat is my Y1 on my calculator. You remember this? My Y1. When you enter the X values under L1, isn't that what it means? Pause the video and think about what I wrote. Y minus Y hat. Y is easy. It's just L2, observed values. Y hat, it's not, I don't know what to say, except that I need to enter the X values in my equation to get the Y hats. Isn't that true? Isn't that what I did here? Isn't that how I got this? So you need to be able to write, this. How do you write it? It's easy. You should be right now on your calculator under L3 equals blank, right? It's blinking because you are here. So it's blinking. Type L2, which is second function 2, you get L2. So that's easy. Stat edit L3, right? So press this button and do L2, which is second function 2, minus, this minus is that minus. Now how do I say this? Pay attention. How do I say this? I want you to click on vars like we did before, and then click on Y-vars, and then click on the word function, and then click on Y1, not Y2, not Y10, Y1, because that's where your function was. Wasn't your function under Y1 on the calculator? So that's going to give you L2 minus Y1. Isn't that true? But I don't want L2 minus Y1. That's silly. That's a list. That's a function. You want to enter L1. So all you have to do, put parentheses and press L1, which is second one. Second function 1 will give you L1. And close the parentheses and press enter. Press enter. And it's going to compute all these green numbers for you for free. And double check if this matches with what you got here. And feel free to do the residual for another point, let's say this point, and see if it matches somewhere in here. I mean, figure out where is that point. I'll put it in red. Pick any point you want, compute it algebraically, and see if it matches with the residual that you got in there. That's how you do it, okay? The last thing I want to say is this. This is a fact. If you add all these errors that I drew here, this is a positive error, positive error, positive error, negative error, negative error, negative, negative, positive, positive. If you add them up, if you add those errors, you should always get 0. That is a fact. And maybe I should prove it to you at the end of the year when we don't have to be pressed by time with the AP. So this is a fact. The sum of the residuals is always 0. So if you want to check, double check to see if you add these numbers and get 0, well, one way to do it is waste half an hour and write 16 numbers and add them up, right? You don't want to do that. Here is how you do it. You go to your home screen and click on list. Go to the home screen first. Click on list, which is second stats. List. Go to math. You'll see the word math. In fact, I'll do it right now to see if it's seconds. Yeah, go to the right where it says math. And then scroll down to number 5, which is the sum. You want the sum. And what you really want is the sum of L3. Isn't that true? So you click on the word sum. And you should be right now on your home screen that says sum, and it's waiting for you to do something. You want to do the sum of L3. So do second 3, which is L3, and press enter, and you should get 0. Now, many of you are not going to get 0. You might get something like this. 1.037 times 10 to the negative 19 or something. That simply means it's 0, right? This is like 19 zeros followed by 1037, okay? The reason it's not going to give you exactly 0 is because all the numbers that are written here, some decimals were cut off, right? The calculator can only handle so many digits. But if I have to write all the digits for the residuals, if you add them up, you will get 0. That's a fact, okay? So if you get a number really close to 0, you know you are correct, okay? So that should end this video. I hope this was helpful to you. And that's how you would analyze this type of data. And of course, I can go back here and talk about the general shape, talk about the association, talk about the correlation, and talk about potential outliers. Now, of course, potential outliers generally will have a very large residual, like positive 15,000 or negative 10,000, right? And it's just based on the naked eye. I don't think this is an outlier anyway. I don't think there are outliers whatsoever. Okay, so that should end the video. Take care.